Swans are overpowered. They can fly, they can walk, and they can swim. Too bad. Here's my model of a drone that can also do all three. It's a drone. It can float, fly, drive, roll to conserve energy. On like from coming down out of hills, and it can go underwater like a submarine kind of thing. So let's talk about the shape first. And I did this with a red marker, so I'm not sure whether or not it's like visible, but so it's shaped like a Bisleri water bottle on both sides, and it's like a cylinder pretty much, except on the both sides. So it's like um, I don't have something to exemplify the shape right now, but it's like any plastic drink that we consume, essentially like any soda bottle. Um, because then it has like an axis of rotation for the rolling part, right? And so that's one thing. Um, Moving on, it will need a battery, a circuit, a controller, a Bluetooth, a camera, and an accelerometer. Maybe more things, maybe something for navigation too and stuff. Also, Bluetooth has bad range, so I'm not really happy with the idea of using Bluetooth to control it. So I'm still in pursuit of better alternatives. Something that works underwater as well, because that's a necessity, right? Um, yeah. Okay. Now, all of these components, the electrical components, should not be exposed to water, obviously, and they should be inside a waterproof body for suspension purposes. And this is the body part of it. So I hope this is clear. It's like a box. Like the top thing is the body itself, like the bottle shaped thing, but inside it attached to like springs or electromagnetic suspensions would be another box with all of these components, and this box would be obviously like very light plastic and like a waterproof kind of thing, so the components don't get wet. And by the way, the shape is so that it's also aerodynamic on the ends, and it needs to be on both sides so it can like without going sideways. Obviously, low weight material will be needed, no doubt, but yeah, the weight needs to be balanced because we also need it to like go underwater, right? And how that would happen is that the wheels would essentially propel it downwards instead of upwards. Like if you're flying, you want to go up, but if you're going to, like if you want to go down, then um, you need to like propel yourself downwards, right? Um, Now, how that would work is that one thing you can do is so I'll get to this later. It's optional, but you can also add a parachute just in case it's like very high. Um, um, yeah, I guess. We'll talk about the spokes later. Let's talk about the wheel first. So, it's basically like the wheel is normal, except that it's connected to these joints, kind of things that can allow it to rotate. Um, so, if this is the body and this is the wheel, first of all, there's like one axis, right? So, this thing, like the thing that connects body to the axis of the wheel, this being the axis of the wheel, the thing that connects the body to it, the vertical line over here, this vertical line, the goal of this is to allow 360-degree rotation of this part, so it will go like whoosh, like in 3D, right? Like, yeah. um and that would allow it to go sideways as well while on ground, which would be really cool for sideways parking and all that. So it allows in the XY plane. Meanwhile, this thing should be able to like go, yeah. So this thing goes down, and this thing goes like up, let me simplify this. Like this part, so this thing like it should go forward like this, essentially. um and it can go like that, and so then it would be in this direction, and yeah. So this will allow it to have thrust upwards or downwards. in the z dimension. So this is the z dimension rotation of this thing. Yeah. So now talking about how you would give the thrust, right? I will move this aside. Yeah, with me I have my cooler. Now it might not be visible, but uh, the fans inside are like not in a straight line, and they are kind of curved. It's like this, like bent, and when it rotates, this creates like wind in the forward direction, right? A forward direction wind means that it goes backwards itself. Um, so this is what I want to use, and I can either rotate the wheel fully to change the direction from upwards of the of the thrust from up to down, because it has to go underwater, and because it will be too light. Um, if it's not buoyant enough, then we might need to push it downwards as well using the thrusters. Sorry, the propellers, right? Um, so one way to do that is to rotate it in the opposite direction, like the motor should go in the opposite direction, which would be, I think, the more preferable method. And the other way of doing that is to flip the entire thing, um, like rotate it and then rotate it like this, so like double rotation, because that would allow it to be in the opposite direction, obviously. um, yeah. So like it will be like a fan, kind of like bent like this as it rotates like this, and this will create like wind. Yeah, so I think this is a very interesting concept, and yeah, I've also talked about the spokes kind of thing, whatever that is. So these thing, the outside, sorry, yeah, the outside circle, it acts as a wheel, but the thing inside, like the fan propeller kind of thing, it acts as the spoke. So even as the car is like going ahead, um, some thrust will be generated, but it shouldn't be significant enough. Um, Obviously, because it's like road friction is much more significant, right? On top of that, I think rotating the wheel and rotating the fan or the propeller is the same thing. Um, so it's like doing the same motion underwater. Um, it's just that the joint and the wheel motor should not contact water or be waterproof. Not make contact with the water seems more realistic. I really want to work on it after 12th, like after my final IB exams, and I hope that's possible. I will need to learn a lot of engineering for this because I want to work on this like independently in a sense, I guess. But I would love support as well from my electrical engineering friends and mechanical engineering friends. And yeah, let's do this. Really cool.